Hello, everyone. My name is Matthew Silva, and I'm going to be presenting on Green Architecture by Brenda and Robert Vale. So, to begin with, I'm going to be giving a little bit of background on who the Vales are, and there really isn't too much on who they are, except for the fact that they both studied architecture at the University of Cambridge, and that throughout their careers, they focus on sustainable housing, and they publish many books and guides that focus on sustainable housing and green architecture, which I'm going to get into later. But other than that, there really isn't too much um, before that. So I'm going to go into their inspiration. They're inspired by global warming, right? This is a huge problem, right? Since the Industrial Revolution, we've been increasing our carbon footprint. We're just pumping carbon dioxide back up into the atmosphere, which is a greenhouse gas and is rising the Earth's temperature significantly, which is causing problems for everyone here on Earth. Right? Sea levels are rising. There's extreme weathers, right? Extreme drought and extreme flooding, and it is causing all these kinds of problems. And so, what they wanted to do to try to solve that problem is they wanted to make buildings more sustainable, right? They wanted to lower the carbon footprint for each building, right? Through the amount of energy that they use, how much water each house uses, and just like the waste of each house that produces, right? So their main focus is on sustainable building design, zero energy housing design, and ecological footprinting. And so, yeah, the just whole focus is just to reduce the amount of carbon dioxide, reduce each home's carbon footprint. So to begin with, I'm going to be showing the Hockerton Housing Project. And so this project is really, really cool, right? They use wind turbines and solar photovoltaic systems to produce energy on site, right? The solar photovoltaic system is just a solar panel, right? So they produce all their energy on site, right? They have multiple turbines, they have multiple solar panels, and they were also even able to reduce the amount of energy and water that each utility uses, right? The lights don't use as much energy, and the faucets, the toilets, the showers, they don't use as much water as a typical home does. And so each home, they average about 10 kilowatt hours per day, right? That's just all electrical, which they produce more than that on site through the wind turbines and the solar panels that they have, right? And the thing that's really cool is that if there's any excess energy that they produce on site, it doesn't just get wasted. What they do is that they export that energy back onto the grid so that other buildings can utilize that energy instead of that energy just being used. So it's really cool that they produce this renewable energy all on site and then even export some of that excess energy. So just so that it's not wasted. Another thing that is really cool is that the project, they collect rainfall on site and then they channel all that rainfall into a reservoir that holds the water for about 250 days. And well, that's the maximum that they can hold it on site. And they could use the water way before the 250 days. But they use this collected rainwater and they pass it through a sand filter and treat it with chlorine so that way they could use it for sinks or faucets, take a shower with it, and just to reuse this rainfall instead of it just running off site and not even be able to use that water. And another thing that is really cool that they use a rainfall is then they can channel it into a different reservoir, which is then um, captured so that it can be used as potable water. And potable water is drinking water, right? It's water that's safe to drink and ingest, right? And it goes through 3 filters before it's being able to be used, which is really cool. So they produce all their energy on site, export any excess energy back onto the grid for other buildings to use, And another thing that's really cool I forgot to mention is that the liquid waste that each home produces, it passes through this reef bed on site, which is this image on the right. It breaks down all those toxins and the bacteria it pretty much just helps cleans up that liquid waste so that it can be reused again. So this is just a really cool project. I enjoy this project. And so another thing that the Vales are known for is they developed a building rating system called Neighbours, right? NABERS, Neighbours, right? It was commissioned by the Australian government, and it's a rating system that ranks buildings on a 6 stars about energy, waste, water, and the indoor environment. And so this rating system is to be used on current buildings, right? Current existing buildings. And so they rate the building, and that rating that the building receives is only valid for 12 months before it has to be evaluated again. So that way that any, just so that the buildings going forward continue to reduce the amount of carbon, reduce their carbon footprint, reduce the amount of energy that they're using, reuse a lot of the rainfall that is captured on site, and just using renewable energies on site to power the buildings and all that stuff. So it's another really, really cool thing that they had developed for buildings. Another one, the Southwa House, which was based on, so back in 1773 they had published a book called the, oh, why am I blanking out it? Is not good. Uh, the Autonomous House. That's what it's called. The Autonomous House. And so this building that they designed, which wasn't built until 1993. That's right, 1993. Literally right there on the uh right here. Yeah, it was built in 1993. And um this book, right, or this house was intended um to be to decrease the home's um carbon footprint, right? They use solar panels on here. They collect a lot of the rainwater and capture it and treat it so that the house can actually use it. It's much similar to like the past project, the one I just talked about, minus the wind turbine. But this whole intention of this house was that they wanted it to be affordable, and they wanted it to be desirable for the public to actually want a home that is sustainable and that is green. And so this set the standard for all homes, right? They wanted to set the standard for all homes, not just for a few. They wanted it so that it was possible to recreate this building over and over and over again, just so we can reduce our carbon footprint and deal with problems such as global warming. So this is like their ideal eco house, and it was really cool because they talked about this back in 1973 in their book, The Autonomous House. And then about 20 years later, they actually manifested this building into reality, which is cool. And now their manifesto, Green Architecture, um, they have 6 principles that they talk about in this book. And principle 1 is to conserve energy, which is that they want to minimize the need for fossil fuels to run it. So they want to to rely more on renewable energies like wind turbines and solar panels, just so we're not using as much fossil fuels and pumping all that carbon dioxide back up into the atmosphere. Principle 2 is working with the climate. This one is really, really important to reduce the amount of energy that a building needs to use, because you can't really design a building that's going to be designed, let's say, in a coastal area, is going to be much different than a building that you design in a hotter drier climate, such as a desert, right? So you have to cater that building. You have to understand the climate and understand the climate needs for each building to know how to reduce the amount of energy instead of, you know, making a building a lot hotter than it needs to be and having to rely on an air conditioning unit, just using a ton of electricity, a ton of just to pump colder air to make to make the interior, more comfortable for people living in them. And so it's really important to be able to work with the climate and understand what the climate is. Um, Principle 3 is minimizing new resources. And so there's one building that is, it's called the R.W. Curran Center in Hampshire College in Massachusetts. And a lot of the parts that this building was built with, it can actually be deconstructed and then taken apart and used in a different project. Once this building no longer serves a purpose and it no longer has a use, you can actually reuse these parts on a different project. And so that's what Principle 3 is pretty much talking about you minimizing the amount of new resources you're using for buildings and reusing, being really resourceful with materials that we already have and resources that we already have and made. Principle 4 is respect the users. There is a theory, it's called the biophilia hypothesis by Edward O. Wilson, and it was all about having people reconnect with nature through the built environment just so that they're be able to make the building as comfortable as possible for the user. And so you just don't want to focus on the building itself. You want to focus on how the experience that people are going to be using in the building itself. Principle 5 is respect for the site. And so with this one is normally when we construct a new building, right, a new home, there's going to be some sort of nature there, whether it's like plants or homes for other animals, right? When we're taking out that area, we're taking area out, something that was already natural. And so you want to be able to not destroy too much nature, to destroy too much of what is already natural and just remove it just so we can put a building there. So you want to be able to respect the site in that way, that it doesn't really affect the natural area as much. And principle 6 is holism, which is just about having this holistic approach to the built environment. And now some architects and designs that were inspired by green architecture by Brenda and Robert Vale is there really isn't a specific architect that built this building right here. Right, this is called the Pret a Manger in uh, uh, it's fuck, what is it called? Dutch building. That's what it is. It's inspired. It's supposed to be based off a typical Dutch home, and it was designed by actual students, right? So students participated into this competition and try to design um, a sustainable building that was actually going to be constructed that could be reused for other typical Dutch homes, um, which is it was really cool. I really enjoyed. I liked this project, and so having to remake all the buildings there didn't really make too much sense because there's millions of buildings that it's already constructed. So this project was showing that we can take our existing buildings and redesign them in a way that can make them more sustainable, right? Make them not use as much energy that relies on fossil fuels and not having to um, just use as much resources as a typical home does. And so this has the solar panels, all the appliances don't use as much energy. And they actually, what this project can do is with this greenhouse that they have there, it captures that heat and puts it into a tank that actually would be pushed back into the house during the winter instead of having to rely on an energy source, right? Like a flame to that which heats up the air to push back into the indoors. This just actually captures that heat instead of having to remake that heat. Instead of trying to reheat air, they use it naturally to reheat air. So this is a really cool project, and it was one that was um, inspired by green architecture.